Ladies and gentlemen, this is your friendly chemistry class. Thank you. No, thank you. No. I'm so happy to be here. I'm so happy to be here. Are you happy to be here? Yes. Thank you. Thank you. This is what we have said so far. We said behavior of elements depends on the structure of the atom. Behavior of atom depends on electronic structure. And what we want to say, we want to go one step even further and say between electrons, valence electrons are actually deciding how the atom is going to behave. So why not we just show the number of the electrons in the outer shell. Just show the valence shell. Last time you saw that how reactive sodium metal is, yes? And when we said sodium metal, how many electrons in sodium metal? Help me please. 11. And then we wrote the electron configuration 1s2, 2s2, 2p6, and 3s1, right? And we said there are 2 electrons on first shell, these are second shells, right? So there are 8 electrons on second shell, and this is third shell, there is 1 electron only. And there are 11 protons in nucleus. So this is the atom of sodium, and you saw how reactive sodium is. Why? It would like to have 8 electrons in the outer shell. It would like to have electronic configuration of neon, which has 10 electrons. So it's this which determines the over-excitement and reactivity of sodium metal catching fire with water, reacting with carbon dioxide, reacting with a lot of compounds, reacting with water. So these electron shares did not affect the property. So can I say, it's really valence electron which decides the reactivity and behavior and bond formation of atoms. So why don't I just show that? Just show sodium has 1 electron in the outer shell. That will tell you a lot about sodium. It will tell you it doesn't have complex octet. It doesn't look like noble gas. It has single electrons where electrons don't like to be single. That is suggesting that sodium has to lose this 1 electron. Sodium has the choice of gaining 7 electrons or losing 1 electron, which is closest, which is the best. Losing 1, right? By the way, did you know where I'm from? I am from planet what? Planet Earth. I'm from planet Earth. Did you know that? Aha. We are all from planet Earth. We are all part of the universe. Thank you. Guys, what if I want to talk about chlorine? How would I show number of valence electrons? It's in group 7A. How many valence electrons? 7. So 1, 2, 3, 4, 5, 6, and 7. Do you see what is this suggesting? 7 electrons in the outer shell, 8 electrons in the outer shell is number of happiness. Is this suggesting what chlorine would like to do? What would chlorine like to do? Gain 1 electron. It doesn't like to lose 7 electrons. It's too far, too much energy. Shortest way, gain 1 electron. So is it fair to say that if I write magnesium, it has got how many electrons in the outer shell of magnesium? How many valence electrons for magnesium? 2. It's in group 2A, right? Group 2A, 2 electrons. Group 7A, 7 valence electrons. Group 1A, 1 valence electron, right? So why don't I make our life easier instead of writing full notation? Another way of trying to predict behavior of atom is to show electron dot formula. These are called electron dot formula. We just show number of electrons in the outmost shell. Yes? Okay. So do you see, if I want to write the electron dot formula for beryllium, which is in group 2A, I must have 2 dots. Magnesium, group 2A, 2 dots. Calcium, 2 dots. You just show number of valence electrons. That is going to suggest behavior of these atoms. How about aluminum, which is group 3A, 3 dots. Boron is in group 3A, 3 dots. Carbon, 4 electrons in the outer shell. Nitrogen, 5 electrons, 5 valence electrons. And oxygen, 6 valence electrons. Fluorine, 7 valence electrons. Neon, 8 valence electrons, right? So we can look at the group number of main group elements. We can show their number of valence electrons, and that's how we show electron dot structure, which is telling a lot about property of that particular atom. You can easily see neon and argon don't need to react. Why? They have 8 electrons, complete octet, number of happiness for electrons, 8. They don't need to react. That's the ultimate happiness for atom. What is happiness for atom? Stability. Not being reactive. Not needing to react. So guys, go guys. Steve, good job, good interaction, good team. Yes, thank you, Austin, Dean's team. Thank you, Ethan's team. 3 teams already. Joseph, I know you. How are you doing? Tired? Doing good. Okay. That's Marina's thing. Yes. Mariah, how is your team doing? Thank you. And Holly, thank you. You are full of energy today, I can tell. Yes, that is Danielle. Good job. Yes, Sadie. I have to quiet down. Jessica. So. Yes, I need more hands. Yes, that's Lisa. Thank you. Brianna, yes or no? No? Okay. You got it? Okay, talk to Brianna. Yes, that's Matt. That's Naomi. That's Kat. Yes. Like Italian, right? Italian Jews handle law. Guys, does this make sense? Yes or no? Yes or no? Thank you. Does it make sense? Charlie, yes or no? Charlie, does it make sense?